If you have any of these symptoms, stop eating gluten immediately. You may have celiac disease. First, let me mention that just a small group of people who are genetically predisposed to celiac disease can actually develop this health condition. But the actual reasons for its appearance have been unclear. A group of medical experts say that it may be down to how certain gut bacteria respond to gluten. What is celiac disease? Celiac disease is an immune disease in which a person is intolerant to gluten. Gluten is the protein found in grains including rye, wheat and barley. According to the latest statistics, almost 1% of the Americans suffer from this disease. This is what happens when a person with celiac disease consumes food that contains gluten. The immune system responds by causing damage to the small intestine. This may lead to abdominal pain, diarrhea, bloating and fatigue, among other symptoms. The medical experts claim that certain gene mutations are known to trigger celiac disease. However, only 2 to 3% of people who possess such mutations actually develop the condition. These are the most important facts about celiac disease. Around 83% of Americans with celiac disease are undiagnosed or misdiagnosed with other conditions. The only existing treatment for celiac disease is a gluten-free diet. Around 5 to 22% of people with celiac disease have a first-degree relative with the condition. Dr. Elena F. Vertu, the lead investigator of the Digestive Health Research Institute at McMaster University in Canada, was looking for the main reason for this disease. Dr. Elena and her colleagues looked at how the immune responses to gluten varied with different populations of gut bacteria in mouse models of gluten intolerance. The findings from this study were published in the American Journal of Pathology. The medical experts examined mice divided into 3 groups that expressed a gene called DQ8, which is found in humans and makes them genetically susceptible to gluten intolerance. Each group of mice had different gut bacteria compositions or gut microbiomes. One group was germ-free while another group was clean, specific pathogen-free. Their gut microbiomes were free of proteobacteria, a group of gram-negative bacteria and opportunistic pathogens. And the last group was made up of conventional SPF mice, which possessed a wide range of gut bacteria, including proteobacteria and opportunistic pathogens such as Staphylococcus, Streptococcus and Helicobacter. All mice were subjected to gluten and the results were the following. The medical experts exposed each group of mice to gluten. The researchers found that the germ-free mice showed increased levels of intraepithelial lymphocytes in the gut. Proliferation and activation of IELs is an early indicator of celiac disease. Increased IEL levels, however, were not seen in the clean SPF mice. And the germ-free mice experienced increased death of cells that line the gastrointestinal tract called enterocytes, alongside anatomical alterations of the small finger-like projections that line the small intestine known as the villi. We can also mention that the researchers also identified the development of antibodies in response to a component of gluten called gliadin among the germ-free mice, and these mice also demonstrated T-cell responses specific to this component. Dr. Elena and her team also found that development of gluten-induced pathology was halted in the clean SPF mice compared with the germ-free mice, but this was not the case when the clean SPF mice received enter-adherent Escherichia coli from a patient with celiac disease. The medical experts have also found that the conventional SPF mice demonstrated greater gluten-induced pathology than clean SPF mice, according to the researchers, so the team set out to investigate whether the presence of proteobacteria, such as Escherichia and Helicobacter, plays a role. On increasing the presence of proteobacteria among conventional SPF mice by administering an antibiotic called vancomycin around the time of their birth, the researchers found that gluten-induced pathology got worse. Specifically, the team identified an increase in levels of IELs. Dr. Elena Vertu said, "These studies demonstrate that perturbation of early microbial colonization in life and induction of dysbiosis, microbial imbalance inside the body, characterized by increased proteobacteria, enhances the severity of gluten-induced responses in mice genetically predisposed to gluten sensitivity." Importantly, our data argue that the recognized increase in celiac disease prevalence in the general population over the last 50 years could be driven, at least in part, by perturbations in intestinal microbial ecology. Specific microbiota-based therapies may aid in the prevention or treatment of celiac disease in subjects with moderate genetic risk. The famous Dr. Robin G. Lawrence of the University of Alabama at Birmingham notes that while these findings suggest the presence of proteobacteria may play an important role in celiac disease pathology, they do not mean that proteobacteria causes the condition. An alternative he suggests is that proteobacteria somehow boost the immune response to gluten or gliadin. Another more recent study has discovered that individuals with celiac disease may be at greater risk for nerve damage. This study was published by Medical News. Thanks for watching and don't forget to share this video with your friends and family.